Hello and welcome to my channel. In previous video of bar plot, we learned how to prepare these bar plots and do a comparison of one feature within three species and check the significance. And now we are going to make different type of comparison. Here we are going to make a multiple measurements within the same group. Like we are going to have first this group bar plots for the one family of Setosa or one family of an iris data, and then we are going to do a statistical comparison within the group of all the. So let's dive in the R and we will check how we come to this publication ready figure. So yes, we are here in our R and we are using libraries like dplyr, tidr, ggplot2, rstatix and ggpubr. We come here and we will run this code here. As we are looking for the data, iris data, which is available in our base R. So you don't need to worry about the data from where it comes. Everybody have in our base R. You just call this data iris and we will pipe this data in the pivot longer and we will choose our columns 1 to 4 and then convert this data into a feature and a values column. And we will run this code of chunk here. As we run the code of chunk here, we can see how it is. Now we got a table of 3 columns and 600 rows and each have a species, feature and values. Now we do some more calculation on this data like count, mean, calculate the standard deviation and standard error mean. And because we are in the start, we are using here group by. We are grouping the data using a species like Setosa, Versicolora and Virginica. And then after doing a grouping in the last, we are doing ungroup or spilling the data back. So the df sum is a summary. So we just run this code here and we will see the output. Again, we got here in a table 12 rows and 6 features like 6 columns, species, feature and mean, standard deviation and standard error mean. What is the next step? Now before we jump, we need to calculate the statistics for our raw data. For our raw data, which was here like in a 600 rows and 3 columns, for this data we will calculate the statistics. Again, we feed here df long and we pipe this data by a group by function using species, and this we give to a new function from the package rstatix pair_t test. And we use a formula here. We need a comparison between the value and the feature, and we use the p-adjust method called Bonferroni badge, and we pipe this another function called add_y position. This function also comes from the rstatix package, and here we use a function called max. Please take the max value and increase the step like a distance between the two significance values when we are showing over the graph by the 0.08, and we run this code here. By the way, pause the video at any point to check the code properly, and you can also find the code in the description below of the video. As we run here, and you can see we got a table of 18 rows and 12 columns, and here we have species, y position values, group 1, group 2, n1, n2, p and p significance like a p and p values and p adjustment. Now next what we're gonna do, now we are ready to prepare our plot using the ggplot function here. So we say the ggplot and here we keep the data df under sum, which was our summary data. It have on aesthetics on the x-axis we give the feature y equals to mean, and as we are making a group columns, so we use the geom call. Please remember here is the geom call and width of the column is a 0.7. We are giving another geom called geom error bar. Here we use aesthetic y mean, y max using a mean minus and plus of a standard error mean. Width of the error bar is 0.2 only. And then we use the facet wrap, and how we are wrapping, we are using tilde sign here using the species and rows equals to 1 because we want to see all the comparison, 3 species comparison in a one row. Scale is stand for here y axis, and we are saying please use free_y like an individual y axis for each facet. And then we give this function to p value manual, and here we are using stat_test which we already calculated, and we are saying please labels as a p-adjust significant and tip of the length is 0.01, and this we are feeding to a theme_classic, which is very clear theme and I really like this theme. And then we are saying, okay, on a left, on a x-axis, please use the name as a feature, and a y-axis mean plus standard error mean. And here we are using a theme, and a theme we are saying axis dot text dot x equals to element text. The angle of the text is on a 45 degree, and h adjustment and v adjustment on a 1. We simply run this code from here, and as we run the code, we can see a very nice graph is pop up, or plot is pop up, and we can see here on a y-axis we have a mean, and each three facet have their individual axis. On the bottom we can see the petal length, petal width, sepal length, sepal width, all are on a 45-degree angle. As we calculate the statistics, so we can see also our statistics, we are getting a very nice significance between the group, between the features within individual species. So like this, we make a group plot or a group bar plot using the statistic or significance. I hope now you learn how to prepare this kind of publication ready graph using a very simple code, and you can use this code for any data. Just you need to feed your own data inside this, prepare your publication ready figures. I hope you like this video, and please subscribe the channel. See you in the next video. Thank you.